Hello friends, I am Prateek Kumar. So in this video we will discuss about work and energy. Well, again, it's an important concept in physics which helps us to solve problems. One approach to solve mechanics problem is involving Newton's laws, where we use those 4 steps we discussed earlier to solve the problem. Work and energy gives an alternative way to solve similar problems, which at times becomes easier. So it's important to understand this concept very well. Now let's understand work first. So let's say there is an object which is kept on the ground, and let's say I am standing on the ground and I am pushing the object. So let's say I apply a force on the object and I apply the force along this direction. Let me denote this force by F vector, right? As a result of this force which I apply along this direction, let's say the object moves. Let's say the object moves from from this position to this position, right? The object moves from this position to this position. So the object moves in this direction, right? And let's say the object moves by dr, by distance dr, and let's say the angle between this force and the direction of movement of the object be theta, right? Then we define the work done on the object W as F vector dot dr vector, right? So F vector dot dr vector. So work done is the dot product of the force acting on the body and the direction, and the displacement of the body. Now, dot product, this can be written as F cos theta dr. So this is the property of dot product. When you have two vectors a and b, so dot product of a and b will be ab cos theta, right? So this F cos theta, let me denote it as Ft dr. So what is Ft? Ft is the component of force. Ft is the component of force along the direction of motion of the object. So we have seen this in the resolution of vector concept. Now what if the theta is 0? So if theta is 0, then it means what? The net force acting on the body basically acts in the direction of movement of the body. So in that case, the work done will be simply F dr. And if theta is 90 degrees, then the work done will be 0, because cos 90 degrees 0. So as an example, let's say I have a string, and at the end of the string a ball is attached, and let's say this ball rotates in a circular direction, right? In that case, the string does not do any work on the ball. The reason is that the tension in the string will act towards the center of the circle, and the ball will move, the velocity of the ball will be in a tangential direction. So the tension will always be perpendicular to the velocity of the ball. Hence, in that case, theta will always be 90 degrees. So the string doesn't do any work on the ball. Now let's understand kinetic energy. So first of all, let's understand energy. So energy is the capacity to do work. If an object has more energy, it has more capacity to do work. In our day-to-day life, when we say someone is very energetic, we essentially mean that that person can do more work. Now energy can exist in various forms. It can exist as kinetic energy, potential energy, and so on and so forth. So kinetic energy is the energy which is possessed by an object by the virtue of its velocity. So kinetic energy in physics is defined as half mv square, where m is the mass of the object, v is the velocity of the object. So this is how kinetic energy is defined. Now let's understand the relationship between kinetic energy and the work done by a force on an object. So as we discussed earlier, the work done by a force on an object is given by, let's say, small amount of work done dW will be given by what? Ft dr, right? Ft, this Ft I can write as, Ft is the component of force along the direction of motion of the object. Ft I can write as mass times the tangential, or the acceleration along the direction of motion of the object, into dr. Now I can write acceleration as what? V by dt into dr. Acceleration is the rate of change of velocity. I can write this equation further as mdv by dr into dr by dt into dr. This equation is essentially the same. Now this dr by dt is what? It is velocity, rate of change of displacement, and this dr and this dr gets cancelled. So this equation essentially becomes mv/dv. So this is what? This is dw, right? So if I integrate this, then I will get total work done on the object. And let's say if I integrate from initial velocity vi to final velocity vf, I will essentially get half m v final square minus half m v initial square. This is what? This is essentially the final kinetic energy minus the initial kinetic energy, which is the change in kinetic energy. So what do we get? The work done on an object is the change in kinetic energy. So this is the relationship between the kinetic energy and work done. So if we apply any force on the object and its kinetic energy, its velocity changes, then the work done by the force will be given by the change in the kinetic energy of the object. Well, so far we have discussed the change in kinetic energy when a force acts on one body. Let's say I have a system of bodies. So let's say I have two bodies A and B, and let me choose these two bodies as one system. So the system will be under the influence of an external force and internal force. So the internal force could be gravitational force between the two bodies, or electrostatic force or magnetic force, whatever. So in that case, the work done on the system will be equal to the change in kinetic energy of the system. However, the work done will be equal to the summation of the work done due to the internal force and the work done due to the external forces. The summation of these two works will be the change in kinetic energy of the system. Now let's move to potential energy. So first let's understand conservative force and non-conservative force. So let's say I have a body, and this body moves from position A to position B, and then it again comes back to position A, right? Now if this body is under the influence of conservative forces, then in the round trip the work done by the conservative forces will be 0. Whereas if this body is under the influence of non-conservative forces, then the work done in this round trip will be non-zero. Now electrostatic force, gravitational force, magnetic force, so these are conservative forces, whereas friction is a non-conservative force, because in the round trip the work done will be non-zero. Now let's say I have two bodies A and B. Let me choose these two bodies as a system, and let's say these two bodies are under the influence of Fc, which is a conservative force. It might be the magnetic force or gravitational force between these two bodies. Let's say these two bodies are under the influence of a non-conservative force Fnc, which might be friction, and let's say this entire system is under the influence of an external force, which is F external, an external force. Now as we discussed earlier, the total work done on the system will be equal to the change in kinetic energy of the system. This we discussed earlier. Now the total work done on the system, this we can split into three works: work done by the external force due to Fxt, by the non-conservative force due to Fnc, and by the conservative force. So the summation of three works will be the change in kinetic energy of the system. Now we define potential energy of the system in the following way. The change in potential energy of the system is defined as the negative of the work done by the conservative forces. So conservative force is what? Only Fc. So the negative of the work done by the conservative force is equal to the change in potential energy of the system, which is UF, which is final potential energy, minus UI, which is the initial potential energy. Please note here that Fc is an internal force. Fc is the internal conservative force. Now if we plug this equation UF minus UI is equal to minus WC in this equation, then we will get WEXT plus WNC is equal to UF plus KF, final potential energy plus final kinetic energy, minus UI plus Ki, final initial potential energy plus initial kinetic energy. Now UF plus Kf is defined as the final mechanical energy of the system, and UI plus Ki is defined as the initial mechanical energy of the system. So the work done by the external forces and the non-conservative forces will be equal to the change in mechanical energy of the system, will be equal to the change in mechanical energy of the system. Now if W external is equal to WNC is equal to 0, then as a special case the final mechanical energy will be equal to the initial mechanical energy. So in that case Kf plus Uf will be equal to Ki plus Ui. Now these two equations are called the principle of conservation of energy. Now let's apply all the concepts we have learned to figure out how the potential energy of a ball changes when it is thrown above the ground at a height of h, right? So let's say I have this earth and this ball. Let me choose this earth plus ball as the system. So in this system, the ball will experience the force of gravity due to the earth, and the earth will also experience the same force of gravity. But since the earth is very big, so essentially the earth will not accelerate, only the ball will accelerate, right? So this force of gravity for the earth and the ball system will be Fc, which is our internal conservative force. Now in this system, there is no non-conservative force and there is also no external force, right? So now let's understand when the ball is thrown above how the potential energy of the system will change. So the change in potential energy, or UF minus UI, which is change in potential energy, is defined as the negative of the work done by the conservative force, which will be negative of work done by the conservative force, which will be Fc vector dot dr vector. R will range from 0 to h. Now what? Now Fc, which is our internal conservative force, it will be mg minus j cap, because mg is acting in the vertically downward direction, and dr will be dr because the ball is thrown above the ground. So dr vector will be dr j cap, right? And this r will range from 0 to h. So this negative will cancel, so ultimately we will get mgh. So delta u, or the change in potential energy of the earth and ground system, will be mgh. So when a ball is thrown above the ground, the potential energy of the ball and the earth system will increase by mgh. Now since the earth is very big and the earth essentially doesn't move, so in normal language we say that the potential energy of the ball increases by mgh. So thank you. Thanks for watching this video. If you have liked this video, then please subscribe to my channel. Thank you.